All right, let's kind of review on the graphs here. Let's do a little review. It's review time. All right, if we had if we had y is equal to 2 to the x, okay, our graph is going to go up like this. If we throw a negative out in the front of 2x, negative raised to the 2x, then the graph, right, is decaying. Okay. If we have, for example, a number between 0 and 1, for example, a half raised to the x, then we have exponential decay. If we throw a negative out in the front of it, like such, then it's going to be a mirror image and come up like this. Right? Okay. Let's look at some other examples of exponential functions. For example, if I had 3 to the negative 2x. Alright, this can be actually rewritten as 1 over 3 to the 2x. Okay. And once looking at this, actually, I could write 1 over 3 to the 2 raised to the x, which, now remember, this is 1 to the x over, and then you multiply exponents, so this would be 3 to the 2x. So there's all different ways of writing this thing. You could actually say 3 squared is 9, right? And write 1/9 over that. So these are all equal. Okay. Now let's get into some exponential equations. For example, let's say that I wrote 16 is equal to, let's say, a squared. And we want to know what in the world is a. Well, one way you can do this is you could raise both sides to the half power. And I know you're like saying, wait a minute, that's not an exponential function. But eventually I'll be getting somewhere with all this. Okay, so 2 times a half is just 1, so this ends up becoming a. And then a raised to the half, remember, it's the same thing as saying the square root of 16, which is 4. And so a would end up equaling 4. So remember, it was 16 equals a raised to the second power, and 4 squared is 16. What if I had 9 is equal to 3 raised to the x? What is x going to have to be? Well, I'll just have to tell you, x is equal to 2, because 3 squared is 9, and this is something that we're going to end up be doing quite a bit of in the next section, or actually I guess in this, maybe in this same section, because I did throw in some logarithmic stuff, logarithms, which we'll talk about next. What if I had 1/4 is equal to 8 raised to the x power? What does x going to have to be in order for us to get this to equal 1/4? What if we did this? 4 raised to the negative 1 is equal to 2 squared. Let's see, it's going to have to be more than 2 squared, isn't it? 2 to the third raised to the x, because 2 to the third is 8.